So in this session, we will discuss questions related to projectile. In the first question, in 15th century, an explanation of a projectile motion went as follows. This is a statement from 15th century. Like when you throw an object, you give it force. They call that as impetus, and it moves in a straight line. It is moving in a straight line until the impetus used up. So until the impetus used up, the object will fall vertically to the ground. So object will come to the ground once the impetus used up. This is the 15th century statement about the projectile motion. Now in the question they are saying correct the diagram to show the path followed by a projectile according to modern observation with the same initial direction. So if we launch a projectile in the same initial direction, so what is the trajectory it will follow? It will follow a parabolic path. So when we represent this, it will be like this. Is it clear? The first part, the trajectory of an object which is following a projectile motion. The horizontal velocity is not affected by, as we assume, there is no air resistance affecting the motion. And the second one, acceleration is due to gravity, which is constant. Look, in this question, the first part they're saying this is a projectile motion which is represented in the 15th century. But correct the diagram to show the path followed by a projectile according to modern observation. So according to modern observation, if we launch a projectile with certain angle, so which path it will follow? It will follow a parabolic path, a parabolic curve will be there that is followed by this object which undergo a projectile motion. Then the next part they're saying explain why the projectile follow the path you have drawn. So the path which we have drawn, we show that this projectile will follow a parabolic path. So why it will follow this parabolic curve or parabolic path? And you should include the reference of horizontal velocity. So why a projectile follow a path which we show? So first thing, we assume that air resistance is negligible. That's our first assumption. And what is the effect of this air resistance being negligible? So the horizontal velocity remain constant. And the second thing, acceleration due to gravity is there. The vertical velocity, acceleration and deceleration are due to gravity. And the last part, the horizontal and vertical component are independent of each other. Like the what is a horizontal component? That does not have any effect on the vertical component. And what is a vertical component? That does not have any effect on the horizontal component. So horizontal and vertical velocities are independent of each other, or does not depend on each other. Is it clear, this part? In the next part, when a toy balloon is quickly hit up at an angle, like if you have a balloon, you hit with an angle, it appear to follow a similar path. Like if you have a balloon and we hit this balloon, what we see, what trajectory or what path it follows, the balloon follows a similar path which is described in a 15th century, that first it will move and then at certain height, after reaching a maximum height, it will return back. So balloon is a practical case because when we draw this path, a projectile path, we assume that there is no air resistance. But in case of balloon, which is a practical case, so there will be a air resistance. And when there is a air resistance, the horizontal component is not constant. So as the horizontal component is not constant, what happens when it is moving forward? The horizontal component is decreasing and eventually the horizontal component will be zero. Once there is no horizontal velocity, horizontal component of velocity is zero, then it will only accelerate due to gravity. That's why it will come down in this manner. And in ideal projectile, what we assume horizontal component does not change. So every point it is moving horizontally or it is having a component of horizontal motion. This is ideal case, but this is the practical case, what happened practically. Is it clear? So when we mention why a balloon follows the same path which is described in 15th century, so what is the reason for that? Air resistance is acting. So if air resistance is acting on the object, the horizontal component is not constant. It will decrease or decelerate at maximum height. When it reaches the maximum height, there is no horizontal component, only vertical component. So the balloon will fall vertically. Is it clear about the motion which is described in a 15th century about the balloon? So basically when this balloon is launched, it is having horizontal and vertical components, but horizontal component is continue to decrease, and about vertical component is also decreasing because it is decelerating. But when it reaches a maximum height, only the gravity is acting, and because of this gravitational pull, it will come down. The photograph shows a model of war wolf, a siege engine used in the 13th century. It is used to attack the castles by firing missiles from the sling. So basically, this is a sling. When it will move vertically, it will release this missile and that will hit the castle. So in the question, to operate this model, a coin is placed in the basket and small projectile is placed in the sling. So we place the coin in the basket because basically what happened when we place an object here, this will move downward so that this will be released. The potential energy will change into kinetic energy. As this basket will come down, the sling will release this missile and it will have a kinetic energy. So potential energy or change in potential energy of the coin is equals to gain in kinetic energy of the sling or the missile. So first they're asking on one occasion the mass of the coin placed in the basket is 0.41. The basket fall through a vertical distance of 7 centimeters, so it must be in meter, so 0.07 meter. Calculate the maximum amount of energy available to launch the projectile. So basically that's a potential energy which is mgh. So mass of the coin, that's given 0.41 multiplied by gravity, that's 9.81, multiplied by height in meters, so 0.07 meter. So this will give us the total energy which will come out as 0.28 joules. The next part, an energy conversion calculation predict that the projectile speed is 16 meter per second. So this projectile is launched with a speed of 16 meter per second, the missile, and it observed to fly out from a sling at an angle of 40. So it's making an angle 40. So it's not exactly horizontal. It is coming out with a speed of 16 meter per second and making angle 40 degrees. Resolve the velocity into horizontal and vertical components. So how we can work out the horizontal and the vertical component? So we have the velocity given 16 meter per second making angle 40. So it will have two components. The component which is with an angle will be 16 cos 40 and the component which is against the angle, that is 16 sine 40. So how we work out, because we can see the horizontal component is 16 cos 40 and the vertical component is 16 sine 40. As we use a trigonometric ratio, we can identify the horizontal and the vertical components here. So 16 cos 40, that will be 12.3 meter per second, and 16 sine 40, that is equals to 10.3. So this will be equal to 10.3 meter per second. 12.3 meter per second and 10.3 meter per second. And how we worked out, we simply use a right angle triangle, as it was this hypotenuse was 16 making an angle 40 degree, and we need the horizontal and the vertical components. So the base, this one is a base, this one is perpendicular, and we have hypotenuse. So if we use a trigonometric ratio, sine theta is equals to perpendicular over hypotenuse. So sine the theta is 40, perpendicular we don't know, that's unknown, and hypotenuse is 16. So 16 is multiplied, so we'll get the value of a perpendicular, which is 16 sine 40. That's why I wrote directly here that 16 sine 40. And when we use cosine theta, that is base divided by hypotenuse. So base theta is 40, base is unknown y, and hypotenuse is 16, so it will be multiplied. That's why it is 16 cos 40. Is it clear? So when the angle with horizontal is given, always the horizontal component is with cosine and the vertical component is with sine. Okay. The predicted range here means the ideal case. This is ideally that this projectile, when it is launched, it should travel 27 meters. That is ideal or scenario when there is no air resistance or the launching angle, because when we have the maximum range when the angle is 45. So if angle vary, the range will also vary with the angle. And in practical, what happens if we launch, it's only traveling 8 meters. So what could be a possible reason? Air resistance and friction, they already mentioned that air resistance and friction in the machine are the responsible reason for the differences. Without further calculation, explain another reason why the projectile does not go as far as predicted. So air resistance and friction are the two reasons they already mentioned. But why other thing? Why it does not go out to the same range which is predicted according to 27? So what could be a reason? Maybe not all of the potential, because what happened when we are adding a coin to a machine, when we add a coin, then it is launching a sling. So the potential energy is changing into kinetic energy. So, and you can see in the picture, this sling is attached with a cord, with a rubber. These. So what might happen? Some of the energy might be stored in the string. So if some of the energy stored in the string as elastic strain energy, so what will happen? It will not reach the same range because the kinetic energy transfer will not be same. So as we calculated in the previous part, that when this coin is coming down, it is 0.28 joules of change in potential. So how much when it is a projectile is launched, the kinetic energy should be 0.28, but in practical it's not. It should be 0.28, but in practical it's not. Why? Because what happened? Some of the energy stored in the string, or not all of the potential energy converted into kinetic energy, as some of the energy stored in the string. Is it clear, this part? That why the range of this projectile is less than 27 meter, which was predicted. When a soft mint sweets are dropped into a bottle which containing a fizzy drink or a carbonated water, there is a sudden release of a gas which forces a long stream of fluid out of the bottle. A student decided to calculate the amount of kinetic energy transferred to the fluid in this process. In one experiment, a student placed the bottle at an angle of 50 and adds the sweets and measure the maximum horizontal distance traveled by the fluid. The student then calculated the fluid left in the bottle. The student then calculated that the fluid left the bottle at a speed of 7.5. Show that the initial horizontal. So how we can show that? 7.5 meter per second is the speed at which the liquid is coming out from the fizzy drink, and it was making angle 50. So how to get the horizontal component? The horizontal component is given by the cosine theta as the angle with horizontal is given. So horizontal component will be equal to 7.5 cos 50. So 7.5 cos 50, that will be equal to 4.8 meter per second. So this is equals to 4.8 meter per second. That's the speed at the horizontal speed of the fluid as it come out. Then the vertical component, how to get the vertical component? So that will be equal to 7.5 sine 50. So 7.5 sine 50, that's equal to 5.7 meter per second. So we got the horizontal, which is 4.8, and we got the vertical, which is 5.7. The next part, use the value calculated for maximum horizontal distance. Assume that the fluid leave the bottle at a ground level. So we have the horizontal component at which it is coming out. That was 4.8 meter per second. And we got the vertical component as well. uh, From it's coming out as 5.7 meter per second. We need the horizontal. So to get the horizontal distance, we need a horizontal component. And horizontally there is no acceleration. So if there is no acceleration and we need a range here, so we have the formula speed is equals to distance or range here divided by time. So we have the horizontal speed, but we don't know the time. Total time for the flight, total time it remain in air. So first what we do, we'll find the time to reach the maximum height. And then we will twice that time, so that will give us the total time. Now, how to get the time to reach the maximum height? So we have the vertical component. We have the vertical component which is 5.7, and at the maximum height the vertical component is 0, and because it will decelerate, so acceleration or deceleration will be minus 9.8 meter per second square, because the vertical component is decreasing. So we have initial velocity, we have final velocity, we have acceleration, so we can find the time to reach the maximum height. So v is equals to u plus at. And whenever you are solving by using an equation of motion, it should always be the vertical components placed, because horizontally there is no acceleration in the ideal case. So initial velocity is 5.7, the final velocity is 0. Acceleration is due to gravity, which is minus 9.8, and time is t. When we solve, it will be minus 5.7 is equals to minus 9.8. And minus 5.7 divided by minus 9.8, that will give us the time to reach the maximum height. So it will be 0.58 seconds. So 0.58 second is just the time to reach the maximum height. So same time it will take to return from maximum height to the same ground level, 0.58. So total time, because when we are finding the range, we need the total time. So total time will be equal to 0.58 multiplied by 2, that's equal to 1.16. So total time will be twice of the time to reach the maximum height. So 2 into 0.58, 1.16 seconds. And now we need the maximum distance. So how we will calculate the maximum distance or the range? So range is speed multiplied by time. But the range depends on the horizontal component, So we need the horizontal component here. The horizontal component already we calculated in the previous part, which was 4.8, and the time 1.16. That's time. This t is the total time, not the time to reach the maximum height. This is the total time. So 4.8 multiplied by 1.16, that will give us 5.6 meter. So the maximum range by this projectile will be 5.6 meters. Is it clear, this part? The next part, calculate the total amount of energy transferred to the fluid. The total mass of a bottle contained and the fluid before is 2.4 and after is, so how much mass of the fluid is being transferred? That is m1 minus m2. That will give us how much liquid will come out from the bottle. So 2.24 minus 0.79, that will give us 1.45 kilogram. That's the total mass. And because we are finding a kinetic energy, so for energy, the speed, the launching speed was 7.5. Horizontal and vertical component of velocities are there, but kinetic energy, we use the speed here, so which is half mv square. So half the mass which is transferred, that is 1.45 multiplied by the speed, launching speed, that's 7.5, and then the square. So this will give us about 40.8 joules. So this is the amount of energy which is transferred to this bottle, transferred to the liquid. The next part, give a reason why your value of kinetic energy might be higher than the true value. So what we calculated 40.8 joules. That's what we calculated. But maybe practically the kinetic energy which will come out, that will only be maybe 30 joules. So why our value might be higher than the other value? So what could be a reason why the value which we calculated, which is 40.8, might be higher? Because we are calculating the kinetic energy by using half mv square, and our assumption is that, like when the liquid is coming out from the bottle, our assumption is all of the liquid reaches this point. But in practical, what might happen, maybe not all of the liquid reaches the maximum, some of the liquid fall in between the liquid particle. But our assumption that all of the mass is being transferred to the maximum distance, maximum horizontal distance. That's why it will not be. That's why our value is higher, because we assume, or our mass is higher as we assume that all of the mass transferred to the, so not all of the mass transfer from the bottle to the maximum range. Is it clear, the first part? That because maybe what happens, some of the liquid might not reach that maximum displacement, horizontal displacement. So that is why our answer is higher. And then they're saying explain why your value of kinetic energy might be lower than the true value. Maybe what we calculated 40.8, but in practical it will be higher. So how in practical it might be higher? Because when the liquid is coming out, we assume that the liquid is coming out at a speed of 7.5 meter per second. But what might happen? The liquid is coming out at a higher speed, maybe 15 or a higher speed. But what happens when it reaches the bottleneck, bottle opening? Because of the friction of the bottle and the between the bottle and the liquid, that reduces the speed. But in practical, the liquid might come out at a higher speed. So liquid is coming out at a higher speed, but we are only getting 7.5. That's why our value will be lower than the true value. Or we can also say the air resistance, when we calculated the speed of the horizontal component, or we calculated the speed, we ignore the air resistance, but in practical there will be an air resistance. Is it clear? The second part, that the friction or air resistance might reduce the speed, which cause a smaller value of a kinetic energy than the true value. In question 4, the photograph shows a sequence of the pictures of a man from 30 meter, uh, jumping 30 meter from a cliff into a water below. Ignore the first picture. So ignore the first picture and consider the second picture as representing the instant he jumped. Ignore the final picture, the splashing, taking the 10th picture as shown. The diagram shows that the 10th picture of a man is it is useful to mark the center of a gravity of a man for each picture before taking the center measurement. State what is meant by center of gravity and mark appropriate position. So what is the center of the gravity? Center of a gravity is a point where whole weight of an object acts. So this will be the position where center of gravity will act on the person. The vertical distance between the consecutive picture increases, but horizontal remain constant. Explain this observation. So what they said here, that the vertical distance is between the picture, the vertical distance is increasing. Like first picture, it is smaller, then it is increasing. You can see. So the vertical distance is increasing, but the horizontal distance remains same between the each picture. So what it shows about the projectile, if you ignore the first, it's because he's not jumping in the first one. So all have the same horizontal displacement. So what is the reason? That's the same reason that horizontal component is constant. That's why horizontal distance is constant. But vertical, it is accelerating, and that acceleration is due to gravity. Is it clear that why the horizontal distances are same and the vertical distance for each picture is increasing? By considering the vertical motion of a picture from 2 to 10, show that pictures are taken at a rate of 3 per second. The vertical height fallen is 30 meter. So the vertical height which he fall, that is equals to 30 meters. And we know that basically first we will find the time to fall this 30 meter. So we have the equation of the motion in which the initial velocity is 0 because initial vertical is 0. Vertically initially is 0. Horizontal is there but the vertical is 0. And the distance travel is 30 meter. So we'll find the time. So we have the formula equation of motion S is equals to ut plus half at square. If u is 0, so this will become S is equals to 1 by 2 gt square. S is a vertical distance which is 30. 1 by 2 gravity is 9.8 and time t square. So 30 multiplied by 2 divided by 9.8 in a root. What we'll get? We'll get a time. So it will take about 2.47 seconds to fall this 30 meter. And how many pictures are there? As you can see, there are 8 pictures. We want to show that the pictures are taken at a rate of 3 pictures per second. They mention here that the word by considering the vertical motion from 2 to 10, show that the pictures are taken at a rate of 3 per second. So how many pictures are there from 2 to 10? So there are, because this is already there, 2 is already there. So when we count 1, 2, 3, 4, 5, 6, 7, and so 8 pictures are taken in this time interval 2.47. 8 pictures are there. So time and pictures. So 2.47 seconds. There are 8 pictures. So in 1 second, how many pictures are there? X cross multiply. So we will get this as 8 divided by 2.47. So this will approximately give us the number of the pictures taken per second, which is about 3.2 pictures per second. Is it clear, this part of the question? So I'll share another link and continue this question. How it is 8? Look, you got the time interval from the second picture to the 10th picture. So this is already there. This is a starting picture. Now the time interval start from here. This, when it is 2 seconds, means time is equals to 0. And when it is at the 10th picture, time is equals to 2.47 seconds. So how many pictures are taken from second picture to the 10th? So this is the first picture, second, third, fourth, fifth, sixth, seventh, and